Hello, welcome to Learning Theatre. In today's video, we're going to talk about the electron transport chain. Electron transport chain. So, before that, this is our mitochondrion. And we have the let me do this. Yeah. Okay. So this one here is transporters, and we also have the outer membrane. This is the outer membrane of the mitochondria, and we have the inner membrane of the mitochondria. That is this portion. The inner membrane of the mitochondria. Sorry, is this one. That's the inner membrane of the mitochondria. And we also have what we call the intermembrane space. The intermembrane space. This space is what we call the intermembrane space. Intermembrane space. And also this whole thing is what we call the mitochondria. So, electron transport chain. The electron transport chain occurs in the mitochondria. And it has outer membrane, as I said earlier, and an inner membrane, and the folding of the mitochondria is what we call the cristae. So cristae, that is the folding of the mitochondria. And also the inside of the mitochondria is known as the mitochondrial matrix. The mitochondrial matrix. The inside of the mitochondria is called mitochondrial matrix. So this space here is what we call the mitochondrial matrix. And where this space is where we have a lot of Krebs cycle activity taking place. The mitochondrial matrix is where a lot of Krebs cycle activity is taking place. Electron transport chain occurs on the inner mitochondrial membrane. So the inner mitochondrial membrane, this space, not the intermembrane space, this space, this line here, the folding line, that's where the electron transport chain is occurring. And also remember that we generated 2 FADH in the Krebs cycle and 6 NADH. These NADH and FADH are going to take their hydride and remember we generated 2 FADH2 in the Krebs cycle and then 6 NADH. These NADH and FADH2 are going to take the hydride they are carrying to this electron transport chain. Yes. So let's begin. The first step is called compress 1 or the NADH dehydrogenase. Compress 1 or NADH dehydrogenase. Now we have NADH, and this NADH will react with the first part of the electron transport chain to oxidize the NAD plus. So this is what is going to happen. We have NADH here, DH, and it's going to react with the first part of the electron transport chain to give us NAD plus. And what is going to happen is that there is a flavin mononucleotide. This is the flavin mononucleotide I am talking about, FMN. Flavin mononucleotide. And this flavin mononucleotide will pick up the electrons from the NADH and convert it to flavin mononucleotide carrying H2. Flavin mononucleotide carrying H2. So it is going to pick the hydride from the NADH and then form flavin mononucleotide carrying H2. Yes, so in the first step, this is what is going to happen. The NADH we brought from the Krebs cycle is going to react with flavin mononucleotide, and then NADH will get converted to NAD plus. It will get converted to NAD plus, and this flavin mononucleotide will pick up the hydride from this NADH and get converted to flavin mononucleotide H2. Yes. So we pass electrons into complex 1, and when we did that, where did the protons go? When we pass electrons into this complex 1, the electrons are pumped into the intermemory space. The electrons are pumped into the protons are pumped into the intermemory space. We are passing electrons into the complex 1 and then pump the protons into the intermemory space. And then this is when electrons are passed from complex 1 to the coenzyme Q. So this is the coenzyme Q. Yeah, so we are passing the electrons to coenzyme Q, and then the protons will be pumped into the intermemory space. It can also pass into the sulfur clusters. Yeah, so what is basically taking place in this complex 1 is that NADH is reacting with this flavin mononucleotide, and when it does that, it is being converted to NAD plus, and this flavin mononucleotide will also take electrons from this NADH. When it takes that electrons, it gets converted to flavin mononucleotide carrying electrons. And when this flavin mononucleotide takes these electrons from the NADH, the protons that remains will then pumped into the intermembrane space. Now, the electrons that flavin mononucleotide is carrying is going to be pushed to this coenzyme Q. Yes, so the electrons this flavin mononucleotide is carrying is going to be pushed, or it is going to transfer it to this coenzyme Q. Yes. So this is the coenzyme Q here. So what this coenzyme Q is going to do is that it is going to pick the electrons from the flavin mononucleotide. So this is what is going to happen. It is going to pick up the electrons from the flavin mononucleotide, and it's going to get converted to QH2. Yes. And when this happens, the flavin mononucleotide will go back to its normal state. That is flavin mononucleotide without electrons. Yes. Yes, so this is complex 1. Now let's move to complex 2. Complex 2. So this is complex 2 here. So in complex 2 is also known as succinate dehydrogenase. Succinate dehydrogenase. So let me write that down. Succinate dehydrogenase or complex 2. So in complex 2 we have FADH2. So FADH2 is going to drop off its electrons, and what is going to do in order to drop off its electrons is that FADH2 is going to react with flavin mononucleotide. Flavin mononucleotide. Flavin mononucleotide. FADH2 will react with flavin mononucleotide, and FADH2 will get converted to FADH. It will get converted to FADH, and then flavin mononucleotide will also get converted to flavin mononucleotide carrying electrons. Flavin mononucleotide carrying electrons. Yes, and this flavin mononucleotide will carry these electrons which it got or it picked from the FADH2. And when this flavin mononucleotide pick up these electrons, it will want to drop them off. It always wants to be alone. So the electron that is carrying, it will always want to drop them off. And what is going to happen is that this is another coenzyme Q. Another coenzyme Q. Coenzyme Q here. This coenzyme Q is the only one throughout this entire electron transport chain that is not made up of a protein, and it can run ahead of step 4. So this is step 2. It can run ahead to step 4. Sorry, it can always run ahead up to step 4. So this coenzyme Q comes back here and then take the electrons that the flavin mononucleotide is carrying. So it will go and then react with flavin mononucleotide and then pick up the electrons. Yeah, so this is what is going to happen. When I pick up the electrons, form what we call QH2. Yes, coenzyme 2. Yes. When you pick the electron from the flavin mononucleotide, it gets converted to coenzyme 2 or QH2, and then the flavin mononucleotide goes back to its normal form. Yes. But this complex 2 doesn't have a pump that will pump the electrons. So this coenzyme 2 is going to pick the electrons and then take them to the next coenzyme. To form a coenzyme 2. Yeah, so it is going to pick those electrons to the next electrons to form coenzyme 2. And this coenzyme is known as ubiquinone. So this coenzyme is known as ubiquinone. Yes, so it takes up the electrons from this complex 2 to form coenzyme 2 known as ubiquinone. Yes. And complex 3. In complex 3 is also known as coenzyme Q. Coenzyme Q. Complex 3 is known as coenzyme Q or cytochrome B. Cytochrome B oxo-reductase complex 3, do it this way, or cytochrome B oxo-reductase. Yes, and this cytochrome B oxo-reductase is also known as cytochrome B C1 complex. You can also call it cytochrome B C1 complex. And this coenzyme 2 is going to pass, this electrons to this cytochrome B. So it is going to pass the electrons to this cytochrome B. So let me do this. Cytochrome B. So what is going to happen is that the coenzyme 2 will pass or react with this cytochrome B. It will react with the cytochrome B. Going to react with this cytochrome B. When you react with this cytochrome B, it then gets back to its original state. When it reacts with this cytochrome B, it will get back to its original state because it have given out its electrons. So when it gives out the electron to this cytochrome B, it goes back to its original state. And look at something here. So this coenzyme 2 here will pass the electrons to this cytochrome B, and this cytochrome B is made up of ions, ion 3 plus, and then ion 2. Yes, so when this coenzyme 2 passes the electron to this ion 3, this ion 3 is going to be converted to ion 2, because when it gains electrons, it's going to ion 3, whenever ion 3 gains electrons, it's going to be converted to ion 2. Whenever ion 2 loses electrons, it gets converted to ion 3. So when this cytochrome B, when this coenzyme 2 gives or react with this cytochrome B, it gives electrons to this ion 3, and then this ion 3 will get converted to ion 2. Yes, but this complex 3 has a pore that pumps the protons into the intermembrane space. So when the electrons are passed on, the protons will be pumped into the intermembrane space. And the pumping of the protons out into the intermembrane space occurs in complex 1, complex 3, and also in complex 4, I guess. Yes. And when the ions are passed from ion 3 to ion 2, it makes ion 2 to be in a high energy state. But this ion 2 doesn't want to be in a high energy state. So what it does is that it will pass these ions that is making it to be in a high energy state to the next side, the next step, which we call cytochrome C. So this ion 2 is going to pass its electrons to cytochrome C. So this is cytochrome C. Cytochrome C. Yes, so this ion 2 will pass its ions to cytochrome C, and when it does that, it will get converted to ion. It will get converted to ion 3. When it does that, it gets converted to ion 3. Also, this cytochrome C has ion 3 and ion 2. Yes, so when this ion 2 here passes its electron to cytochrome C, ion 3 will gain these electrons and then get converted to ion 2. Yes, so when ion 2 passes its electrons to ion cytochrome C, ion 3 here will gain that electrons and then get converted to ion 2. Yes. Now the last complex 4. Complex 4. This complex 4 is known as cytochrome oxidase. Cytochrome oxidase. Yes. So this cytochrome oxidase, what is going to do is that this cytochrome oxidase, what is going to do is that it will this cytochrome oxidase consists of cytochrome A and then cytochrome A and then cytochrome A3. Cytochrome A and then cytochrome A3. So what is going to happen is that the cytochrome A and the cytochrome A3 consists of ion 3 and then ion 2, like the first cytochromes. So cytochrome A and A3, they all has ion 3 and then ion 2. Yes, so again, this ion 2 here in cytochrome C contains electron that is making it to be in a high energy state, and it doesn't like it that way. It doesn't want to be in a high energy state. So what cytochrome ion 2 in cytochrome C is going to do is that it is going to pass on the electrons to cytochrome A and cytochrome A and A3. And when it passes that electron to cytochrome A and A3, it will get converted to ion 3. It will get converted to ion 3. And then this ion 3, when it gets converted to this ion 3, the electrons that was received in this complex 4 will make ion 3 here get converted to ion 2. So ion 3 here in cytochrome A and A3 will gain that electrons and then get converted to ion 2. Yes. So ion 3 means high energy levels, and ion 2 means high energy levels, and then ion 3 means low energy levels. So now in this cytochrome oxidase, ion 3 here is low energy level, and then this ion 2 here is high energy levels. So this cytochrome oxidase has a pore that will pump the protons into the intermembrane space. So like I said, we pump protons in complex 1, complex 3, and then complex 4. These are the complexes or the steps in which we pump protons into the intermembrane space. Yes. So let's say I have oxygen here. I have oxygen somewhere here. I have oxygen here. Let's say half oxygen. It's half oxygen. Yes. This half oxygen, specifically atomic oxygen, half oxygen. Yes. So this half oxygen is going to react with this ion 2. This half oxygen here is going to react with this ion 2. This ion 2, remember this ion 2 is in the high energy levels. So this half oxygen will react with this ion 2. And when we react with this ion 2 would pass on its electrons to this half oxygen and get converted to ion 3. So let's see what happens. So this is what is going to happen. So So ion half oxygen is reacting with ion 2, and this ion 2 is going to form ion 3, and this oxygen here too, this oxygen here, let me make it this way, this oxygen here is reacting with this ion 3, and as it is reacting with this ion 3, this oxygen, this half oxygen, as it is reacting with this ion 3, will pick up the electrons from this as it is reacting with this ion 2, the half oxygen will pick up the electrons from the ion 2, and plus it will get combined, or plus 2 protons. So we will add 2 protons to this reaction. 2 protons to this reaction. So 2 protons will be added to this reaction, and when this protons is added, we form water. Yes. So ion 2 was in the high energy levels. It doesn't want it that way. So this half oxygen here will come and then react with this ion 2. Ion 2 will release that electrons to this half oxygen, and ion 2 will get converted to ion 3. This half oxygen will take that electron, and plus 2 hydrogens or 2 protons get converted to water. So this oxygen here is the final electron acceptor in electron transport chain. Thank you for watching. See you in our next video. In our next video, we're going to bring the part 2 of this video, or of the electron transport chain. Please like this video, subscribe for more of this.